Hello, I'm Mark, and welcome to my Unreal Engine tutorials on how to create a data-driven sound and visual effects component for your Unreal Engine games. So there's a lot of these videos out on the internet, and so I want to do something with a little bit of a spin. So we're going to be using sound and visual effects. We're going to go ahead and wrap that into a data-driven component. And then we're also going to go ahead and tie in the AI hearing. So as you can see here, I've got my character running around on the grass and on the wood. And as you can see, the notify in the animation is being called on each step that they're making. And as I get closer to the orange sensing dummy, you can see if it hears me. And then if I walk away, you can see that suddenly it loses track. It doesn't hear me on the grass, but then if I come up on the wood, it'll hear me on the wood. So this is going to be using the physics materials. So we'll be sensing what on each step. We'll be sensing what material we're touching, and then that will then determine what effect and material sound we want to use. And then based on that, we can also then set the range and the loudness for the AI sensing. So if we have AI, so if we wanted to create a stealth system, right, we can then factor that information in as the base information that you can then use to compute additional values. So if you wanted to have a stealth system, right, if your characters are on wood and they're running on wood versus walking on wood, you take the base value and then you either scale it up or scale it down. So we'll go into all of that. And again, all of this is all going to be run or configured through a simple little data table. So as you can see here, this is the table that we'll be creating, and this is what we'll be then putting into our character to use. And we'll just organize it so you can and for this tutorial we'll set it up so you can either use Niagara or the in the process of being deprecated particle system. So there'll be backwards compatibility for the particle system, but we'll also go ahead and set up the sound system so we can make the sound with the particles. We'll allow you to give you the ability to change any volume and pitch, as well as any start time on that sound if needs be. And then we'll have a little Boolean check here if you want this sound to also be picked up by AI sensing in your code. And again, this is all going to be done through C++. And so we're going to be making some components which are highly reusable and highly scalable. And as you can see, here's a little bonus. We'll make this so that it's also, you can create variations of this sound too. So this is footsteps on wood. So if you wanted to have something like, say, heavy shoes versus soft shoes, and that would have a slightly different sound and slightly different AI sense, you can customize that within the data system without having to go and make changes in your code or looking through blueprints and code and having to tweak that. So again, trying to put everything into one place so it's a bit more easily manageable, especially when you're building games and as they are evolving in the you just going into a data file and changing the data is a lot more easy than having to dig through code and hope your testers find all the bugs. All right, so that's kind of what we're going to be working on. So we'll be building the table. We'll be building the component as well as the little class here to manage our table. So I'm going to be focusing on surface effects. I do have a component for volume effects. I won't be doing that in this video, but when I put this solution on my Patreon page for my Patreon subscribers, they'll be able to get both sound and visual effects. So I'll leave a link below for that. But yeah, so this is kind of what we're working on in this series. So as always, we have a lot of ground to cover, so let's get started. Okay, so for this project, if we open up Unreal Engine, I'm going to be using, this video is going to be recorded in 5.7 version. So under games, I'm going to be using third person. We want C++, because that's how we roll on this channel. And I'm using desktop, and I'm going to elect to use I like using scalable versus maximum. It just, that way I can always set it to maximum if needs be. And then give it a name, hit create, and once Unreal Engine has done its thing, it should give you a solution that looks like this. So again, content, we have the character, you've got input, level prototyping. So, oh good, they've got some level prototyping stuff in here. That's always good. Not that we need any of that. Under third person, we've got the blueprints. We'll be adding to this probably in the next video when we after we've done all the coding, we'll then integrate it into blueprints. So that's ready for us. We really don't need any of the variation stuff here, but if you want to play with it, you can. But let's move down to the C++ classes and let's get started with our very first class. So like any data-driven system, we are going to need data structures first. So to do that, we're just going to right click and we're going to hit new C++ class. And no, they still haven't got a blueprint for structs. Would be nice if they had done that. So what we're going to do is we're going to actually create a struct. To do that, we are going to come up here to go to none, and we'll then take this class and convert it into a Unreal Engine structure. So let's do that. So I'm going to go ahead and hit next. And I like to use the public-private system, so make sure you're hitting public. We've got public folders there. We're using the correct runtime. That's the only runtime we have in this project. All right, so let's go ahead and name this class. So I'm just going to come over to my other solution real quick. And try and pull this up. Okay, so I'm just going to call it Core Sound Effects VFX Row. I'm just going to, this is a very generic name. Since I'm probably going to need I'm going to be using I'm going to create two structs, but we're only going to be focusing on the physics, the physics sound, which will be the one which we're going to be using for anything that collides. But I'll also put the structure in there that I'll be using for volume as well. So core sound, VFX row, public, everything looks good. So we're going to hit create class, and then we'll let Unreal Engine and Visual Studio do its thing in stubbing out the structures that we need. And then we will then take that file and convert it to our purpose. Okay. Alright, so I got live coding on, so I'm actually going to turn live coding off. I really don't like live coding. What it does is it does a patch. This, if you're using this and you're wondering why when you go ahead and use live coding and you close your solution and reopen it and all the work that you've been doing is not there, well, that's because live coding just creates a temporary patch instead of doing a full compile. So if you turn live coding off and you hit compile, then what it's going to do is it's going to do a full compile each time instead of a patch compile. So like I said, I just turned it off. It's just more trouble than it's worth for me anyway. Alright, so I'm going to pull out Visual Studio and let's go ahead and just bring out the Solution Explorer real quick. Alright, so here we are. We've got our class, but we want a struct instead. So what we're going to do is I'm going to take this, and actually we're going to do a couple of things. Let's go ahead and first get all of the additional includes that we need. So we're going to need, for this solution, we're going to need the Chaos Engine interface, since we're going to be dealing with the physics materials. I'm also going to need the include to the Niagara system. As you can see here, there's a red squiggly. We will fix this red squiggly in the build script, and I'll show you how you can do that. But for now, it's going to say I can't find it, even though it's technically under the Unreal Engine 5 plugins. And So, and then we're also going to need the engine data table, since we are going to be creating data table structures within this file. And then finally, I'm going to need this generate.h as well. Make sure when in C++, if you're new to C++ and you're working, then just make sure that this generated.h is always at the bottom of your include stack. And you can see it's a red squiggly here too, because this hasn't been generated yet. So again, we'll fix that. All right, so getting started, I am just going to go ahead and tell you what, we'll just push this down for now. Let's go ahead and fix this Niagara thing real quick. So to fix this, since we're using the system and we need that, we need to go into our core live. So for me, it's core svx live build.cs. And when you open up, you're going to see these are the dependencies. And so what we need to do is we need to go and add the additional dependencies that our project is going to need. So for that, under Slate, I'm going to put a comma. I'm going to add Niagara. And since we're also using the physics, I'm also going to add the physics core as well. So that should satisfy for our dependencies. But we also can fix these. We can also go ahead and improve our include paths as well. And so I'm also going to do the same thing for our Niagara engine code. So here I can do a comma and then add that for the Niagara system. And that should take care of the row here. Should take care of it. Visual Studio is taking a little bit longer to catch up, but that should take care of it for when we do the compile. All right, so now that that's done, let's go back to our structures and let's go ahead and start building these things out. So the first structure I'm going to do is the base structure. So I'm going to be building these structures for, kind of like inside out. That way when the compiler compiles, it needs that way it's going to go from top to bottom in the file. So any structure, any of the structures which are using for the data tables, they'll be at the bottom. Any of the structures which are within those structures should be in order up top. So the first one is going to be our core FX, sound. So, and I'm just going to make sure we're going to use the right API. So that's. And as you can see here, again, it's looking for a Niagara system. It's up there. Again, the Visual Studio is just taking a sweet time to try and figure that one out. So for this, I'm going to be using Object Pointer. Unreal Engine in 5.3 and above is trying to get away from raw pointers, and they want you to kind of use this object pointer structure now, or type. Instead, so we're just going to wrap this. So this is an object, just like the particle system. So this is Niagara, this is particle, right? And by default they're null pointers because we'll in the data table we'll set that. We have the emitter scale, which is a structure. So the emitter scale allows us to scale these. So if you're kind of like wanting, that way we can use the same kind of emitter. But maybe for different things, like say a dragon's going to have a larger blood spatter than a frog, so you can scale rather than having to have two emitters, one for a large animal and another one for a small animal. You can use the same emitter and just scale it down or scale it up based on what you're doing. So that's what that's there for. Use sound, again, it's a pointer. This is what we're going to be using for our sound file. And then we've got volume, pitch, and start time. I'm making these floats. Usually I like to use doubles, but again, we're working with some more legacy code for the sound. And as of, I think, 5.6, 5.7, I haven't noticed them change that to double yet. So it's still using floats. So I just don't want to have a potential truncation problem there. And then AI sense is the same way. So again, this is our AI sensing. So we have AI sense loudness and max range. And then we also have the AI sense tag. And so the tag is useful. This can be useful in allowing your AIs to filter out sounds. So it may be picking it up. So this could be useful if you've got a game in which your character can both be on the land and swimming at the same time. So if you have aquatic animals, you don't want them to be listening if you're walking, but if you're swimming, your aquatic animals can listen, and your terrestrial animals, will not be able to hear you. Things like that. So you can use it as a filter, in addition to your AI sense loudness and max range, as well as being able to turn it on or off in the file. Okay, so that should be it. So again, this is just using the struct. We're using an F on here. Again, this is just the prefix that Unreal Engine likes for structures. And then the generate body, since we're using this generate H, we can use the generate body and make this a blueprintable structure. So this structure is now available in the blueprints. All right, so that is that's our default. This is the base class, which allows us to manage each unit. So the next structure is the next level up in our table. And that is going to be, let's go get the right API name, switch that over. All right. So this is our map. So this allows us to create variations of this if we need variation. If you need variation, if you don't, then you can probably skip this, or you just use the default. But if you are looking for some variations on the same kind of sound, you can just add one extra layer in there, and that's what this does. So this allows us to create the map, and this is also where I'm putting the sound attenuation as well. And then we have a little helper function here called get sound VFX, where we just put the name in and the sound. You can do this anywhere. I just decided to elect to put this on the struct, since it's a helper function to really just navigate this map here. And so since that way I can just put it in one place and just reuse it. And let's go ahead and fix this. Let's see if this puts it in the right place. Core sound VFX rows CCP. All right, looks like it's going to put it in the right place. Okay, and all I'm going to do, I'm just going to go grab this and put this in. All right, so as you can see here, this is the map. We're going to check to see if the name is in the table. If the name is in the table, then what we're going to do and see. So what we have here is an ampersand. So this is reference. So what we're going to do is we're going to be putting an empty structure in by reference, and then this is going to then by ref fill it, and then allow us to use it as an out parameter. And it's also going to give us a Boolean check. So it's going to do two things at the same time. It's going to fill this so we can use it. And we can also check to say, yes, it's valid. So pretty useful there. And so if this all works, it returns true. Otherwise, if it doesn't contain this, we return false. And that's all that does. Okay, so I don't need this, so I'm just going to go ahead and remove it. While I'm here, we can keep all of that there. Let's come back to the row. I am probably just going to go ahead and just remove that class since it's not needed. All right, so we've got the sound. We've now got the map. And let me come back to my other project. So this is kind of where we can create two variations. And so I'm just going to bring both these. I'll bring the first structure in first. And so this is kind of more for volume. So with volume, we don't need to worry about any of the physics materials. So you can just call it as is. So, because volume is just happening in space. These are things like muzzle flashes or explosions, right? they have sound and effect, and they have sound, distances, but they're more volume effects, and so you could use this for that. And all it is it's just taking the map up here and doing everything. And then we have the surface effects, and that's what I'm calling this. And here it's going to a little bit different because we're going to have this physics surface. And this is an enumerator. This is part of the physics system, and this allows you to create a list of physics materials, and this allows us to map that physics material to the record right here. And that's kind of what we've got going. So if I was to go grab that, let me just go find that real quick. All right, so if I bring back the project, so if let's go find that table. So here's the table, here's my footsteps. So this is the enumerator that we're creating. We have default, grass, and wood, but this is actually being defined. Go ahead and close that up here in project settings. So if I open this up and we go down to physics, down here at the bottom of physics, right, you've got grass. I've added surface type 1 as grass, surface type wood. You can have up to 62 materials, physics materials, defined this way. And so what this does, it allows to create, and then there's the default. So if it doesn't hit anything, it's just going to use the default type. So you can have up to 32, 64-bit programming. There's actually a default, and then there's a max, which is hidden, but then there's 32 in between. So FYI. But yeah, so I've predefined these up here in the project. So our project will go ahead and add these, and we'll get back to this in the second video when we start setting everything up in the solution. The first video is just going to be all C++ and getting that out of the way. But yeah, so that's kind of where that's going to map. So let me close this and bring this down. So that's what this little thing here is. And in C++, we need to say enumerator as byte. And then this is just a surface type, and then we're just going to add the same core VFX. So I'm just going to close that since we're really not going to be using that for this video. But yeah, so that's all of our data structures. So that should take care of our data table. So, and again, this is sound, and then this is inheriting from table, and same with this one. So this is the one that I'm using, that I'd be using for volume. And then this is the one I'm going to be using for surface hits, surface hit effects. Okay, so now we've got that out of the way. So we got the row implementation. We've updated our build script. Just double check to see if there's nothing else I need to put there. Niagara, physics core, AI module. So if you're using AI sensing, you're going to need to make sure you've got your AI module there as well. Again, this package went and added it. But if you're using a different project, or if you're using this in a custom project, just make sure that if you're going to be using AI sense, the perception system, then you just need the AI module, because that's where that code is located. And then I've also got the Niagara system here. Okay, so I think next what we're going to do is move on to, let's move on to the component and get this into a nice little component so that we can manage it in our character through a component. So okay, so for the first thing we're going to do is I'm actually going to build a subcomponent. So right now we've got our table structures, we've got the build file. So let's go ahead and build this little subcomponent. So to do that, I'm just going to move this off screen real quick. I'm going to come down to the content drawer. I'm going to go into classes. And so if you come under here and you're wondering where your structures are, Unreal Engine doesn't like to put structures up here, only classes. It is there, so I'm just going to right click, say new class. So for this, this is going to be more of a sub-component before I get to the actual Unreal Engine component. And I'm going to make this as a uObject. And the reason why I want to make this a uObject is because I want this is a class that can technically live, it can live in the character, it can live in a vehicle pawn, it could live in an actor, it could live in a projectile, a weapons master. You might want to use this in a lot of other places where you might either want, where you might want this. So I'm just going to use it, create it as a simple little uObject. It doesn't need any of the additional overhead. But I do want it to be managed, still managed within Unreal Engine. So I'm going to go under All Classes, Object, hit Next, make it public, make sure we've got the public folder there, and let's give this a name real quick. And I'm electing to call this, I'm going to call this Core Physics Surface. I'm calling it Physics Surface because this is going to be surface effects and surface sounds and surface effects. So that's what I'm going to do. So Core Physics Surface. I'm just, if you wanted to, you could put it in a subfolder. I'm just going to put it all in the same folder since this is just a small little demo project. So do that. Again, hit Create. And let Unreal Engine and Visual Studio do its thing. Let it compile. All right, cool. And now if we come to C++ and we come under here, we should see a public folder, and then there's our first Unreal Engine class. So let's bring the project over again. Just make sure if you get a pop-up and it says reload all, just click on reload all. Just makes it a little bit easier. And I'm just going to close that little message. I don't need it. All right, so this is what we've been given. And so the first thing I'm going to do is I'm going to put an include to our struct. And it's not under data, so let's just do that. So this is the new structure system that we have. So core sounds, VFX row. So that's what we want there. I'm just going to put I always like to put a space, that way I know that this is always going to be at the bottom of the include list. Let's go ahead and set this class up so that it can be discovered by the editor. So we're going to make it blueprintable, default to instance, and edit in inline new. So that's what we have there. This is using the prefix of u, so this means it's a uObject, and it's deriving from uObject. All right. Under generated body, I'm going to put a public section, and that public section is just going to have the default constructor. We're really not going to do anything with it, but it's now there. I'm then going to add a protected section, and under here we're going to have a couple of things. I'm going to have the Unreal Engine, the U table. This is going to be a raw pointer, but that's okay. Still works. And this is going to be the effects table. So this is going to be our surface effects table, which we'll map that in there. And then the way this is going to work is that if we're using a table, it will then fill on load, on initialization, it will go ahead and fill this list up. This is where we're actually doing the work that way. And the reason why I wanted to do it this way, it feels a little bit weird. But if we have it in effects table, then we can then just pull it. It's a lot faster to find kind of query the the sound we're looking for by the surface effects type if it's in a map, then if we had to iterate through the table every time, we needed to find this. So this was done a little bit more like for performance, but also you know, if you've only got maybe one or two effects that you want, or one effect, right, that you need, then you know, someone might say, well, putting in a table seems a little too much. So instead, you could just go ahead and just add it manually. So the way the system's will work, if this doesn't have anything, we'll take from the table and pull in, or if there's a table there, we'll empty this and pull it in. Otherwise, if you don't have a table, we'll just go ahead and use what you've manually added. So some flexibility too. And then, so that's under protected, and then I'm going to add another public section, which is going to be where our functions are. All right, so as you can see, we've got 3 functions here. We have a protected function and 2 public functions. So the initialize physics list, this is kind of like an initializer that we want to run, which will then say, is there a table? Yeah, and this kind of sets this struct up here, ready to be used. And then we have the play material hit effects. So this is going to then take the hit result, the variation name, and then it's going to out the variance. And the reason why we're outing this is because I could technically, we're going to run most of everything we need within here. The only thing that I'm not going to run within here is the AI sensing, and the reason why I don't want to run it here is that if you've got a stealth system or there are some other variables that you want to take into account, you might want to do that either in a component or back in the class. So that's why we're going to have an output variable for the variance as well, so that we can play with AI sense outside of this component. All right, so that should do it. So let's go ahead and get the implementation done. So let's see if this will put it in the right place. All right, so first thing I like to do is I like to do a table check function. It just makes things a little bit easier. So all I'm going to do is I'm going to check to see if this table's a null pointer. For this video, I'm just going to go ahead and just put the engine add on screen debug message, and in red it's just going to say effects, effects table not loaded. Now this could be something that you might want. You might not want the table, and that's okay. But I just did this so that you'd know if the table's loaded or not. So. All right, next we have the initialized physics list. So I'm just going to go there, open this up. And I'm just going to put it. So the way this is going to work, so if I have something to find in this list, then we're not going to bother with the table. So if this list is empty, then we're going to assume that you want to use a table. And then if there's a table, then what we're going to do, so the way to get to iterate through a table and add it into a map is what we need to do is we need to go and get all the rows from the table. So this is kind of how you can get all the rows from the table and put it into an array, right? And then what we do is we iterate through the array, and again this is a structure of pointers, so we're just getting the pointers, and then we can iterate through the array, and then we can add add the values to the map. So that's how we can do that there. So that's querying a table, so we get all the rows, and then we can just iterate through the rows, looking for what so you could use this if you just wanted to query the table as well. This is how you'd query a table. So but what we're doing is we're just taking the table and transferring it into a map so that we can get a faster lookup based on the surface type enum instead. All right, so next I'm going to come up here, and there's our hit effects. And then from here, this is our material hit effects, so this is where the magic is going to happen. So let's go ahead and grab all this. And as you can see right now, I've got a couple of red squigglies. So we're going to be using gameplay statics. We're also going to be using the Niagara function library, as well as gameplay. So gameplay statics, this is kind of a legacy statics class. which is a function library that is being used for the sound, but it was also used in the legacy spawn emitter. But when they came out with Niagara, they actually created their own library. So let's go ahead and grab those includes. So I'm just going to come up here. So this is for Niagara, and that should satisfy that. There it is. So that's the Niagara function library. And then this is the gameplay statics library, which we'll be using. So that satisfies that. So let's just walk through this real quick. And I'm just going to go ahead and open this up, since it's a little bit long. All right, so what do we have here? So again, first thing we're going to do is check to make sure this is not empty. As long as it's not empty, we can then start using it. So we're going to take the hit result. So the way this is going to work is that we need to do a line trace. We're going to do a raycast on every footstep, or every footstep that we have a notification on, right, to check to see what we're stepping on. So this is going to do the trace, this is going to get the actor, and then what we're going to then do is we're going to go into the map by the material surface, get value. So this is kind of how you can get that information out. So we have our find, and again our map is based on that enum, and that's the enum that we're going to be getting out here. So this is the hit result, physics material, surface type dot get value, and that's going to find it, and then that's going to get our VFX map. In there we want the variant, because that actually has a map in, there's a map of a map. And that's what the effects variant is. So if there's variation or the variance, we can use it. If it's just a default, then you just add default. So we'll check to see if we get a variant. If we get a variant back, we're all good. If we don't, if this fails, if this fails, if this fails, or if this fails, we'll return false. So again, it's a Boolean with an output. Otherwise, if we get all the way down here, we're going to create a transform. So with the effects, because this is a surface effect, we want the effect to kind of go in the way, so, if this is a spark effect, right, we want the sparks to come out of the material that it hit. If it's a blood effect, the same way. If it's a splinter effect, those kind of things, right? So we want it to track based on the normal of the mesh that we're hitting. So we want the normal. So to do that, we want to create the transform, and we want to make sure that we rotate based on the normal. So we're going to make, so under rotation matrix, there is a function called make from XY, and we're going to take the hit result normal, and we're going to take the hit result normal. So there's the X, there's the Y. So we're going to be passing the normal in for both the X and the Ys. And then what we want is the rotator. So this is actually going to rotate the matrix. We just want the rotation on the matrix. And then since this is a transform, we also want the location. So there's the location, there's the right rotation, and then this is the emitter scale. So if in this variation we want, for this file, right, for this character, we want to scale it down or scale it up, that's where we're going to put the scale in. And that's on the emitter transform. So next, we're going to take the hit sound. So if there is a sound to this, and there may not be, it may just be an emitter and no sound. We're just going to, so if there is a sound defined, we're going to go take the sound, and we're going to go into gameplay statics, play sound at location. It's going to require a context, so I'm going to you can either use get world or the this pointer, so it's kind of flexible in that regards. It's up to you on what you want to do. I'm going to just, it works either way, so I'm just going to use the this pointer. There's the variant sound. There's the location, so we don't have to worry about the rotation on sound, just the location of it. Then we got the sound volume, the sound pitch, the start time, so if there's changes to that, we can put that in there. And then we also have any attenuation, so that's where our hit sound attenuation comes in. All right, and so that will play the sound for us at that location. And then what we're going to do is we're going to check to see which emitter, if there is emitter defined. So if there's no emitter defined, we're just playing a sound, we just play the sound. If there is emitter, since Niagara is going to be the first class citizen, right, then we're going to check to see if it's there. If it's there, then it's like, then okay, then let's go ahead and do it. So again, we're going to be using the Niagara function library, and on there it's got a spawn system at location. We're going to be running this function. There's the Niagara emitter template, and there's the transform location, the transform rotation, and we want the rotator, right? And then 3D scale. So this is scaling it up or scaling it down by the emitter scale here. We're going to set some flags. So let me just do this real quick. So as you can see here, so this is the auto destroy. So this is something, right? It's going to create itself, run, and then after it's finished running, we're going to tell it to automatically destroy itself. And then we also have the auto activate. So as soon as this runs, it's automatically going to activate. So it's not going to wait for another trigger to activate. And then we have the pooling method. We're just going to set that to none. And then last, we have, let's see if I can get that. I think this is, what is that? Pooling method. Destroy, activate. Oh, that's culling. Yeah, so this is going to auto cull as well. So that's what that's set there for. All right, so as you can see, a lot of things can be done with the spawn system at location. But, you know, backwards compatibility with the existing system, with the legacy system, right? So if we're using your legacy, we're going to use gameplay statics, spawn emitter at location, again, get world. And then we have the variant. Again, this is our, we're using the particle emitter instead of the Niagara. We can just put the whole transform in for this one. So true, again, I'll open this up real quick. So if it's set to true, this is the auto destroy. Actually, which one is it? There it is. That's auto destroy. So again, we want it to automatically destroy. And then this is the pooling method. We're just going to set to none. And then this one's again putting things in different places. This flag is the auto activate. So if you want this, if you want to have the ability to set this in the file, all you have to do is just add these flags into the data structure. I've decided right now that I'm just going to just run. These are just this is just going to happen no matter what. But if you want more control, again, you just add it to the data structure, the flags to the data structure, and you can pass those in. When it comes to pooling method, again, you might, again, they're both using different enums. So you may have to have one for Cascade, one for the legacy, and one for the for Niagara. If you don't if you don't need backwards compatibility and you're always going to use, you can just remove this, and you can go ahead and just add these additionals if you want to. Again, for this video, we're just going to keep that as gospel. All right, so, and then here, this is the out variant. So again, this is everything to execute the sound and the effect, but I also want to tie this into the audio, into the AI sensing. So we're just going to go ahead and return a copy of this back out so that it can be used by another system for AI sensing. All right, so that should do it for our subcomponent. So let's go ahead now and move to the next component is actually going to be a actor component, and that's where I'm going to go and wrap this up to the next level. And that actor component is then going to be the thing that I'll eventually be putting into the character class. Okay, so the dict component, let's go ahead and do that. I'm just going to come in here. I'm going to go to content drawer, go to C++, public. So here's our, this is our little subcomponent. So next up, I'm going to go ahead and make our actor component that is going to be used within our character class. So to do that, I'm just going to come here under common. You don't need to go into all classes. I'm going to select actor components, and let's go ahead and hit next. Again, I'll keep it in the same level just to kind of keep things together. And let's go ahead and name this component. And I'm just going to go ahead and just call it core SVX component. And let's go ahead and create it. All right. Compiling. Let's see. All right, cool. All right, so let's go ahead and bring this up. I'm going to hit reload all. All right, so this is all the boilerplate code that we get when we create a actor component. So let's go ahead and start filling some of this out. All right, so first off, let's go ahead and I'm going to go ahead and add the include reference to my physics surface component. This is the subcomponent we just created over here. So that's what we're going to, this actor component is going to have. So you can put this into, it depends on how you want the architecture of your class. I'm just going to put this in an actor component and then add this to an actor. But you could also just put this straight into the character if you wanted to. Again, that's why I kind of wanted to build this as a uObject. So it makes it very flexible to use. And also by being a uObject and doing it this way, you could also pass it by reference as well to whatever else you want. You know, so if you've got a projectile, right, coming out of a gun, you don't necessarily have to have this in the projectile. This can actually be in the gun. You just pass the reference to the projectile once it's spawned. That way you don't have to worry about when the projectile gets spawned, it's got to then initialize this table. It's already been initialized at the gun, so you just have to pass a reference to it, and then it then just goes back and then uses whatever's in the gun, providing if it's a very fast projectile. If it's a slow projectile, you could just go ahead and put it in the projectile itself, because all of this would have been handled, the initialization phase would have been handled before it makes contact, hopefully. So all right, so again, coming back to here, we're just going to go ahead and wrap this into a nice little component, just make it nice and neat. So first thing I'm going to do is I'm going to just add a couple of little debugging things. So that's my little debugging variable I like to put into all my components and classes, so I can turn debugging on and off in the blueprint. There's our reference to our component. Again, I'm using the object pointer, so it's not so this is not a raw pointer. Again, Unreal Engine's trying to move away from raw pointers. You can still use them, but if you're trying to create components within plugins, the plugin manager tends to complain. So that's why I'm kind of packing it this way with the object pointer. Then I'm also going to set the variation. So this is our default variation, but again, if you wanted to have different things, you could set those name tags and then pass the one in, but I'm just going to use default. And I'm actually going to be running the tracing algorithm in this component rather than in the notify. Some videos have them running the trace in the step, in the notify itself. I'm not a big fan of that. Instead, I'm just going to have the step be more generic and then just run the trace here. So this can be a little bit more specific to the use case that it's going to be done in. Tick component, that can be left. And for now, I'm just going to use make footsteps. So keeping it pretty simple. All right, so now let's go ahead and define these functions. So I'm just going to go hit save. And come over to our implementation file. So within implementation, I don't intend this thing to tick. So by doing this, I'm pretty much saying that this component will never tick. even if you try to turn tick on in the blueprint, this will kind of override that. So, and this is just for optimization. This is just purely a component. There's there's going to be no component tick. So if you know you're not going to have any component tick events, then just turn that off for performance. Next, so we have this guy here, right? And we've got this guy defined, but I want to instantiate it, an instance of it. So to do that, so because if it's in the constructor, we're going to use the create default sub object. This is our sub object, and then this is the name of the sub object. So that's how you can do that. And that's the surface effect, and this is our uObject. It's just going to be created within the constructor. At begin play, we're going to go ahead and initialize it. So if it's using a table, we're just going to pull those table records into that map, so that we can index that material a little bit faster, without having to keep looping and looping and looping. So should make for a bit faster index. Then let's go to the components. So Visual Studio is not giving me a green squiggly on error message, so I'm just going to go ahead and manually bring that in. So again, if I have, pretty much, actually, if debugging is on, then it'll print this out. And that's whatever error message is being piped into here. So that way, if you wanted to put any debugging messages in, if you're trying to debug it, you go ahead and just use this little utility and then turn it on and off in the blueprint. And then get step trace. So let's go ahead and fix this guy. So this is the step tracing that we need to do. So every time we're going to hit, what we want to do is we want to figure out what material, this is going to give us the result of that trace. So we've got this get step trace, hit result out, and we have the character. So first thing I want to do is I want to make sure we have a valid character coming in. So this can be I'm using a character. If you want to make this more generic, you can use this as an actor, right? If you want this component to be a lot more generic. But since I know this is going to be used in a character for this, I'm just going to use a character. If you're going to use an actor, then you'd probably need to then just cast it. If it's a character type, you'd probably want to cast it, but otherwise you should be fine. Alright, so the first thing we need is a character start location, and as you can see, I've got a red squiggly, so let's go ahead and fix that. I'm going to bring in two includes for this. The first one is going to be game frameworks character, which is where the character class is. But then I'm also going to bring in the capsule component, and I'm going to be using this to help determine the line trace down. And this can be useful to do it this way. That way, if you've got a character whose capsule is shrinking or growing, and that could be, if you've got a game in which your character can then go into a crouch position, and you want to shrink the capsule to keep that, so the capsule's a little bit smaller while your character's in a crouch position, then we can still have the same hit trace. We're just going to recalculate that based on the new capsule height. And to do that, that's all we have to do. So we have a start, which is the actor location, and then we have an end, which is going to be the actor location minus the capsule component, scale capsule half height, and then I just added a little bit of a buffer of +5. to it, just to make sure that that trace is, there's a little bit more of a trace coming off that, coming out the bottom of that capsule. So that's all I'm doing there. But again, the half height. So if the half height changes, the line trace will adjust accordingly. All right, then next, we need to set up our hit and our collision parameters for our ray trace. So here we're going to do a force initialization on the hit. So there's our F hit. And then we also need collision parameters. So the first thing we want to do is we're going to add the character, because we want to ignore this character. We don't want to include this in the trace. We only want to we only care about what's outside of the actor, right? And then because we want the physics material, we want to turn this to true. So by default, this is off, so it kind of saves a little bit of extra compute. But because we want to know what's under there, we're going to turn this on. So we're going to set that to true. So for this, I'm just going to use a single line trace. If you've got something which is a little bit more complex, you may want to use a multi-line trace. But I think a single line trace is usually good for nearly everything. So what we're going to do is we're going to do a single line trace. Here's our output result, start, end. We're going to be anything that's visible. That's the collision channel. And then there's the collision parameters. And since this is turned on, this trace will also it will also add to the hit result what physics material we're hitting, if we're hitting a physics material. And then I'll just go a little bit of debugging there. That way you can see the line trace. If you turn this on, we'll be able to draw a line. So this is using draw debug line. So get world, start, end, color, and true. And this is just a Unreal Engine line trace that you can use, and it'll just go ahead and draw one out for you if you need to see where those lines are being created, or that trace line is being created. All right, again, don't need tick. So then the only other thing we need here is the make footsteps for material effects. So I'm just going to go ahead and do that. Create that function. I'm going to copy this and paste that into there. And as you can see here, here's our AI sense hearing report noisemaker. So we're going to go ahead and add this. So this is where we're going to add the noisemaker. So let me see what I am missing. Oh, here it is. And so I'm going to come back up to include. So the AI sense hearing. So this is what you're going to be sending to, and then this will send it out to. This will then distribute it out to all the AIs which are listening. So all the AIs are tied into a dispatcher. And they're listening, and then so this then gets cast and sent to it if they have perception. So there's the perception, there's the hearing, and as you can see, once we add that include, AI sense hearing is good to go. If you're doing this and you're not seeing it, just make sure that you've got your AI module here in the in your dependencies, and that should fix that for you. All right, so here what we're going to do, so this is going to be called on every notify, and we'll tie that into a custom notify shortly. So this is we want to execute this function on every step, and what this is going to do is it's going to then take the get owner of this component, cast it, and that's the character. We're going to then create a hit result, which is the force inline hits. And we're going to go ahead and pass that into our trace. Yep. So that is going to be the trace in. Actually, you know what? We don't need this guy. Yeah, we're not using this guy, sorry. So under get step trace, you don't need this hit. We actually need to move this up one. We can keep the collision parameters down here, but we need to move the hit up because we need that hit to pass into our component here in the play material hit effects. So yeah, just remove that. So that's where our hit is. So that's where we define it. We pass hit in. We've got the character. We're passing the character in, but we want the hit to come out. So that's why this is a hit out, an out hit. So out hit comes out. So then we're also going to create a variant. So this is where we want the variant to come out of this guy. So that's why this is so that we can then use this in AI hit sense. And that's what's in this component here. And again, I pulled this out because, again, this would be where you would then, if you needed to do any other compute on the loudness, you could do it here if sense is set. Again, so this comes out. So if we have a surface effect and the surface effect is played, right, and this is true, then we'll then check to see if AI sense is turned on for this effect. If it is, we're then going to pass this to the report noisemaker event. And again, just do this for you. So you can see that's the world context. So you can use get world. This is the location of the noise event. So that's the character location. This could be the character location. It could also be the hit location as well. So it's up to you. I'm just using the character location because that's where the character is, but if you really want to get accurate, you should probably use the hit location instead. So, and then the variant, as you can see here, AI sense loudness. So there's our loudness variable. There's the instigator, so that's who's instigating the sound. So since this is a footstep, we're going to use a character. If this was a projectile, a bullet, or a missile, or a torpedo, then that would be the actor that's instigating the sound. Again, if it's a using a laser raycast shot, it might be the gun. For the muzzle, if you've got a muzzle flash and the sound, again, this is just where the sound is being instigated. And then this is the AI sense max range. So again, there's our max range. So this is the maximum range it can go. So range and loudness, and we'll play with this a little bit in the next video when we start setting this all up, so you can get a sense for. And the nice thing about it being data is you can play with those variables. And then this is the tag that we're sending. So all of that is being sent out to whatever's listening for it. All right, and we'll just go ahead and just take this out since I don't need to know about that. All right, so that should be everything that we need here. I think, yep. All right, so next up, let's go ahead and set up our custom animation notify that we can then use to capture this based on the animation and trigger the make noise based on the step. So let's go ahead and do that. Okay, so the first thing I'm going to do is I'm going to come over here. We're going to come to the content drawer. We're going to go to C++ classes, public. So now we've got a component, a subcomponent. So what I'm going to do here, what I like to do for something like this is I actually like to use an I'm going to create an interface first. So this interface is going to be something that anything that I want to use this notify to bubble up to, right? I'm going to go ahead. I don't like the idea of casting to a list of objects, right? To see if is it a player, is it an AI, is it an animal AI, is it a car AI? I don't like that. Instead, I just like to create an interface, and this interface has got a couple of functions. Just does this object have this interface? If it does, then we can go ahead and execute it. Otherwise, if it doesn't, don't bother. So that's why I like using the interface. This is just one cast versus having to do a bunch of cascades. And then if you forget to add something later on as your project grows, you know, then you've got a now bug where you can just keep this simple and reusable. So that's what we're going to do here. So I'm going to go ahead and create an Unreal Engine interface. So this is under Common at the bottom. So just scroll down to the bottom, it says Unreal Engine interface, hit Next. And I'm just going to call this Core Character Noisemaker Interface, but you could also just call this Core Noisemaker Interface, because if it's going to be going onto something more than just a character. Under Public, again, make sure the runtime, we only have one right here, so we're good. So let's go ahead and create an interface. Alrighty, so let's come to classes, C++, and as you can see now we've got the interface here. Let's go into our project and reload all. So, okay, so this is the generic boilerplate, and I'm just going to add one function here, which is going to be footsteps. So this is real simple. So the way that this works, if you're new to interfaces in Unreal Engine or just new to interfaces in C++, you just have to make a class which uses the prefix I. This allows us to know that it's an interface. And then just make it virtual void and equals to 0, right? If you do this, then this is virtual, 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 which means it must be defined in whatever is going to be inheriting this interface. All right, so now that we've got the interface and we don't really need to do anything in the implementation, this is purely definition. All right, so now that we've got that, let's go back and create a custom notify. So to do that, let's come into the content drawer and go right click, new class again. We're going to come to all classes this time, since it's not really, a notifier isn't really a common custom class. So we're just going to come here, and all I'm going to do is just say animation notify. So anim notify, so this is the default notifier, and as you can see there's other kinds of notifiers. You can also do notifier states as well if you wanted to create a custom notification state. So if you're looking to, if you need to create a custom notifier for your animation, this is kind of how we do it. We're just going to go with the basics, which is the animation notifier. But again, if you needed something which needed to have a start and a stop, you'd then probably need animation state instead. But yeah, so this is just the basics. And then if you needed something like a play montage or play a Niagara effect, you can create a custom, and you wanted to then expand on what they have, or play sound, and you want to do something custom there, like say have a data table for the sounds, and some custom logic. You could then take this, extend it, and to do what you needed to do. But we're just going to use the basic animation notify here. So we're going to hit next. Animation notify, so let's give this a name. So I'm just going to call this core animation notify, and of course underscore footstep. It's just this is kind of how I do it, so I can find it in the editor. And again, making sure it's public. Right, runtime, hit create, and we'll just let Unreal Engine go ahead and stub that out for us. All right, so let's come back and we'll hit reload all. And this is what it's created, as you can see. So if we go into definition, maybe, right. So if we go to definition, I can do this. You can see kind of like the structures which in it, but this is the uObject animation notify, and as you can see here, there's a bunch of virtual. If you come in here and these are all the functions that you can, if it's got virtual, you can override this and either replace it or kind of expand upon it, the logic. So as you can see here, this is with editor. and then this is the stuff that we're going to be using. So as you can see here, please use the other notify function instead. So this is what we can expand upon. This is the notify. Notify, as you can see, it's in the process of being deprecated right now. So there's probably, let's see if there's which other does it want to use? As you can see, you've got post load, pre-save, get world. So all right, so we're just going to go ahead. I'm just going to go ahead and just use this since it's still there and we can still use it. And it really didn't specify which new function it's using, so we're just going to go do that. So just going to close that. And let's go ahead and just go grab it. So here's our notify. This is our skeletal mesh. This is the animation sequence. This is the override. So this is what we're going to do. And so when you're overriding a function, just you just put the same thing in. Just say override. As soon as you say override, then it will use your function and not use the function there, which is in the base. All right. So let's go ahead and create this real quick. Just gonna go grab the code. And as you can see, I need to add a couple of things. So first off, I've got the my little manager here, and then I've also got my interface, core character interface. So let's go ahead and do that real quick. Hit save. This is the actual character. So let's go ahead and let's see, which we actually don't need because we're using an interface. So yeah, we just need, so this is the reason why I like using the interface. So here is just the interface. So what we're going to do is we're going to take the mesh, we're going to get the owner of the mesh, and we're going to cast it to the iCore character noisemaker interface. So if this mesh, right, if the owner of this mesh, it can be an actor, it can be a character, it can be, a pawn, right? If that has this interface on it, then it will cast back and we will have a good cast. Otherwise, if it doesn't have it, it will come back null and we won't execute. And then from here, as you can see, here's our debug to say if the notifier is being called or not. So I've just got it there. And then all we're going to do is we're just going to execute this function. Again, this is on the interface. So, and by doing this, again, this makes it a lot easier. So you can use this notify now for anything that is got, and then all we have to do is just make sure that your character has this interface on it in the C++, and we'll get to that, I think, next. All right, so that should do it for noisemakers, footsteps, and again, the implementation of the notify. Okay, so let's bring this home for this video. So let's go into the core. So this is our character. This is the character that we're going to be using in our little test game. So within here, we've, as you can see, Unreal Engine's created us a lot of things already. So we just need to tweak this for our purposes. So first thing I'm going to do is go and add ourselves our includes. So this is the component and this is the interface. And as you can see here, I've got some additional things on there. All right, so I'm just keeping everything in line in this project. So as you can see here, we've got that. We have the noisemaker interface. So now we just need to have this thing implement that interface. So I'm just going to go put a little comma there at the end of the inherited class and add the interface to it. Now that this interface is here, it's going to be looking for a function. And I am going to put this under, I'm going to put this under public right here. Actually, you know what? I'm going to put this up here. So this isn't a blueprintable function. I'm just going to keep this here as is, make footsteps, you know, because this is being used by the notify, so I don't need to make this blueprint callable. So, but it is going to, but this is the same function that is on our thing here. And then in order for us to use it, we're just going to use override. And then that's going to allow us to override it on the interface so that we use what we need. So we'll just leave that green squiggly there for now, real quick. I now want to go ahead. So as you can see here, we've got the spring component, we've got the camera component. I'm just going to add my component to it. So just copy that in. There's the component that we created with our SVX manager. And we just make it the same as these three. All right, so now we can move over to implementation to go ahead and implement this stuff. That's game mode. That's what we want. Close game mode. All right, so again, this is all boilerplate that it's created for us. So this is just setting up the character movement with the values that it wants to use, as well as the camera locks and rotation. We're not going to touch any of this. We're just going to add to it. So there we go. So again, this is a component. So again, this is how we can set this up. Create default subcomponent object, sound and video. And this is just here so that it shows up in the blueprint, sound and visual effects manager. This is just my little manager for that stepping sound. Again, I'm creating a component that I can then add additional things in there later on, but that's what that's for. We don't need to touch anything there. We don't need that. We don't need any of this stuff. Do jump. So then the only other thing we need now is to go into our make foot step and go ahead and derive that. And then all we're going to do is just going to add that function. So this is just a wrapper. So again, and so we're doing it this way, so that way we don't have, so our notify is now more generic for any step, for any character. It doesn't have to be a player character anymore. It can be for a, for anything that we want to, which we want to have this component or something similar, right? It doesn't really matter. So the interface is now implemented. We've got the component in there, and we've got the and then we've got the way to actually access it on that component. All right, so I think this is going to do it for this video. So we've got all the C++ taken care of. So in the next video, we'll go ahead and move over to the editor and start to update the. We'll need to create our. We'll go ahead and create all. We'll create the assets. We'll go ahead and create the table. We'll go ahead and then we'll go and integrate everything together. We'll create the AI bot, so the AI listener dummy, so it can listen, and we can kind of close that loop so they kind of see all of this in action. So that will be video 2. As always, if you like what I'm doing, feel free to like and share my videos, as well as subscribe to my channel. And if you have any questions, feel free to leave them in the comments below. And yeah, have a great day, and I'll catch you in the next video. Cheers.